All right, guys. I've kind of been alluding to some of these ideas about the scope of the studies that we're going to be taking a look at and what we can conclude and to whom do we have the right to make those conclusions about. Okay, and so that's what this next little set of notes is. And again, if you watched the two article videos, I've kind of led you to some of these items that we're going to talk about at that time as well. All right, so the scope that we can make about studies. So the first one we're going to talk about is the experiment, okay? So that was our placebo surgery article, okay? That was an example of an experiment. So definitionally, this says that when you have that well-designed experiment, you're comparing at least two treatment groups, okay? You also have that random assignment, okay? And then you have to have that replication. So we'll talk about in another lesson that the principles of experimental design, you got to control what you can, randomize the rest, and repeat amongst several subjects. So as we move forward and talk really more about what we can say about experiments, first of all, here's the unique trait. Experiments have treatments. Experiments have actual treatments. In our first experiment, that was debridement, lavage, the placebo. Okay? Your treatments could be 0 grams of the medicine, 15 grams of the medicine, 30 grams of the medicine. There are treatments. That's the defining characteristic of experiments. Plus, the other defining characteristic of an experiment is that subjects have to be randomly assigned to those treatment groups. You put them in a bag, shake well to randomize them, and then pull out the ones to go to that treatment, and that treatment. It's very important because look here at what this random assignment is doing, okay? Important to understand that. When you are doing that random assignment to the treatment groups, then what's happening is that you're hoping to distribute or spread out any unknown traits, hair color, eyes, weight, blood pressure, family genetics, whatever. You're just taking all of those things and spreading those out. So hopefully every group has the same kind of people in each one. Some of them have small, medium, and large people. Then there's men and women in that group, and there's brown hair and red hair in that group, and so on. And there's those things in this group as well. Okay, you're spreading unknown traits evenly to the treatment groups. When you do that, and if you have all the same kinds of subjects in your treatment groups, the only difference is the treatment. And so, if the only difference is the treatment, then if the surgery works, this kind of surgery works in this group, and the placebo surgery doesn't have any results, the only difference, so therefore the only difference is the treatment. Then we say, whoa, the only difference between these two groups was the fact that they had debridement and these people had nothing. So that means the debridement is the cause. That's the key. That random assignment, which makes the only difference between those groups, therefore, any significant change are because of the treatment. Therefore, when we make generalizations for experiments, okay, the what can we claim? We have the right to claim cause and effect. Big deal. Now, who can we claim it to? To whom can we generalize these results? This is where it's limited. Technically, you can only say these results about those volunteers, those ones that were in that experiment. And I struggled with this for a long time. I'm like, well, then what good is that? Okay. If I can only say it about those volunteers. And the reason for that is because those particular volunteers, they may have had a particular quality different than the general public. Okay, they might have been more desperate to improve. They might have been more diligent in their physical therapy. They might have traits that are different than the general population of people who have knee pain or whatever. Okay, so we can say due to those volunteers or ones similar to those volunteers. A lot of times, what happens is they'll do a small experiment, and if they see that this has potential for good results, then they'll expand it to a much broader group of people and do like 30,000 people or whatever. So, to hopefully have a much more broader range of subjects. Okay, that was experiments. Now, here's our observational studies. That was the one with the coffee. Remember how we were kind of like, what's happening here? What can we really say? Do we have info to do this? We talked about the prospective and the retrospective things. Here's the defining characteristic of the observational studies. There is no treatment in those in that article with the caffeine and the skin cancer. They didn't say, hey, you people, you drink a whole bunch of caffeine, and hey, you people, you do not drink caffeine, and we're going to see if you do not get skin cancer, or who gets skin cancer. We're going to see. No, they just took data. They just collected data on do you drink caffeine, or and did you get skin cancer? Observed them in their natural environment. Subjects are just observed. All right. Because subjects are just observed, that's not, um, hurting anybody. That's not doing anything to the people. Like, I mean, you're not telling them what to do. You're not assigning them a treatment like the experiments. Because of that, we then can just usually we just can randomly select from the population. I can say, hey, let me just pull a pure random selection. I'm going to do randomness, put everybody's name in a big bag, shake well, and pull out 110,000 subjects like they did in that one second study that we had on the caffeine. So they did that, looked at all those medical records, whatever. Well, random selection from the population will make it such that we can then generalize to the population. All right. So random selection. So that's different than up here. We had random assignment. Assignment is putting them into the treatment groups. Okay? Putting them into the treatment groups. Random selection is just, hey, let's just kind of select randomly who's going to be in this, who we're going to study. Okay? All right. Next, so the goal of that random selection is to reduce bias, and we hadn't talked about that randomized to reduce bias song yet, but we'll talk about that here in a minute. So we want to do random selection to reduce bias in that selection of subjects, and because those subjects don't have any particular or special traits, we can generalize to the population, like what I just said. All right. Final thing about observational studies. What scope, what do we have the right to make what generalizations do we have the right to make? Okay, well, first and foremost, no cause and effect. Okay, there are typically other things at play. With our caffeine article, sun exposure is something that could also be at play with all of those subjects. Okay, we did not control it so that these people, only had the only difference between this group and this group over here was the caffeine. Okay, it wasn't controlled such as that. All right. You can say there's a trend, there's a relationship. It looks like there's an association. It looks like the more caffeine you drink, the less skin cancer you get. So there's a negative relationship. All right. Now, to whom can we generalize our results? Well, that's the beauty of this. We can't say much, just an association or relationship, but the beauty is we can generalize to the entire population if we had done that random selection. Okay? All right, so very important facts. Now, I think on the next page it does some more summary. I got these two little songs here. I'm not going to go through that. There's that randomized to reduce bias. Okay, if we talking about this, let's actually just talk about that real quick. Our subjects, they go in the bag, and I shake them well. So I'm going to subjects, they go in, and shake them well. Subjects, they go in. I'm gonna shake my big bag. I shake 'em well. Okay, so here we go. Look, I talked about this. When you need to spread unknown traits evenly. When you need to spread those unknown traits evenly to the treatment groups, you're going to randomize. You're going to randomly assign and spread those unknown traits evenly to reduce bias. Reduce bias. Randomize to reduce bias. Reduce bias. Randomize to reduce bias. Okay? Now, this song here, I don't know if you remember all about that bass. Okay, but this one does two things. It talks about random selection versus random assignment. Okay, so let's just look at the lyrics real quick, study those. So, random select. So, you randomly select, no effect. Okay, I say this no effect because the random selection doesn't mean we can do cause and effect. No, it was that random assignment that allowed us to do cause and effect. Randomly select, no effect. When your samples like the population, you can generalize. That's the key right there. Random selection says that when your samples like the population, you can generalize. Random selection. Okay, so now let's go take down here. But look, when you make an experiment, you must randomly assign. So you're randomly assigning to make the treatment groups the same, or to make the subjects in those treatment groups the same. So the only difference is your treatment, and your treatment is the why. When you make an experiment, you must randomly assign to make the groups the same. So the treatment is the why. Ba-dum, ba-da-da-da. So that's your cause and effect. All right. This summarizes it down here. Purpose of randomization. What happens is my students go, oh, I say, why do we randomize? And they go, reduce bias because of the song. Yes, that is true. But you can't disclude this. We reduce bias with randomization, but you spread unknown traits evenly. When you need to spread unknown traits evenly, randomize. Randomize. When you need to spread unknown traits evenly, randomize. Okay? All right. Therefore, if the only difference is that treatment, then you can do cause and effect. Here is another good summary about random assignment versus random selection. Okay. So I hope that those notes make it clear for you the conclusions, what you can do with observational studies versus experiments.